Alright, here is my assignment 1 for Foundations of Artificial Intelligence, and I will start first by running this program, just to give a feel for it. Alright, so basically the way it works is you input start, hit enter, you get a prompt. We'll just go with easy, and that's just referring to the state to choose, and then I'll blow this up. So basically then the second prompt has you choose your strategy. In this case we're going to choose BFS, and then it goes. So basically what it does here is it's giving you the specified output that we were supposed to include. So it gives you the state, it tells you the action depth, and the total cost. Whoops, okay, I skipped a little bit ahead there. So yeah, so there it is. So it's the state, depth, all of that. So now let's jump into the code itself. So we kind of saw how the user interface works. Basically, start is the only thing that you need to worry about, and it kind of signals those prompts, which then get you to input the proper state and everything that you, and the search strategy to then use. So jumping then into the nodes, this is where kind of the node structure includes all of the general stuff they were supposed to include, state, parent, children, etc. And then I found it useful to also add in some of the different costs associated with some of our later search strategies. So I do have an AS1, A-star search 1 cost, and an A-star search 2 cost. And I just found it easier to include those there instead of finding another way to keep track of them. It just seemed a little bit more fluid that way. So kind of then getting into some of the creation, this is where we create the node. Creating the root, you don't need anything other than the state, so that's really all that is set there. And then kind of moving into creating the successors. Final ordering I decided on was left, up, right, down for how the list of those successors is generated. And then looking at a specific specific successor, kind of show how that works. So first we determine the state itself. So that calls a move left function in this particular situation, and what that determines is whether or not a move left is actually legal or not on the game board. So then it returns the new state of the board, or it returns a marker to then signify to another function to have it removed from the list. And then it sets up all of its information there. So moving down, looking at some of those creation methods, primarily these are just to kind of make the above code for generating successors a little bit cleaner to look at, except for the one that is doing the sort of creating of the A-star search 2 cost. So all of the work to kind of generate the Manhattan distance is actually done in here. And basically the way I do that is I basically take the distance, basically each of the game boards is really a list in the code. So I calculate that distance from one position to the next, and then kind of conform it, basically kind of determining what distances would equate to different movements on the board, and then I could calculate exactly how many movements each distance would equate to. And so I found it best to just kind of put those in a condition and kind of lay them out here in terms of how that all happens. So looking at the general search function, all of the different search specific code actually funnels through here to then spit out a lot of information in terms of outputs that we saw when I ran the code, and also doing all the manipulating of adding things to the visitor list, adding things and removing things from the queue as well. and also state checking the queue and the nodes that are looking to be added to the queue. So what this search helper does here is this actually calls a search strategy, which then will kind of set which type of search we're going to be doing. And so basically what that equates to is just finding the proper way to sort onto the list, or sort the queue. So for example, here is uniform cost sort. So basically we want to determine the best way, or I'm sorry, the most efficient way to a solution via the path cost. So that's what the sort is doing here, and basically it's just inserting one by one a member of the successor nodes onto the queue, and then it just kind of iterates until it finds its proper position. So that is pretty much it in terms of the kind of the highlights that I wanted to include from that. So that's it.